Hello and welcome to this wonderful webinar. Today we're going to be presenting information architecture from data products to knowledge graph. And who's going to be presenting, you might ask? Well, Andrea Gioia is the presenter, and he is the CTO, partner of Quantica, as well as co-founder of Blind Data. Andrea is also a chapter leader at Dama, Italy. He is currently writing a book presenting ideas around this presentation as well this summer. But I will let him talk further on that. And yeah, the floor is yours, Andrea.
Thank you very much, Joaquin, for having organized this super interesting event and having invited me to have a talk today. And of course, thank you also to all the ones that have joined the presentation live streaming now. The presentation is about information architecture, and specifically we'll see why data management is not actually about the management of data only. There is more. In order to extract value from data and produce insight and finally drive action that produce tangible value, we need to build upon data and information architecture that make the data themselves actionable. So we will see the structure of this information architecture, the different layer and components for each layer during this presentation. So Joaquin have already introduced me. My name is Andrea Gioia. I'm a partner at CTO in Quantica. Quantica is a consultancy firm based in Italy and operating all around Europe, specialized in data metadata management. I am also one of the co-founder of Data, that is a governance platform, SaaS-based and cloud-based, centered on the concept of data product. If you want to reach me, you can connect to LinkedIn, or you can check my profile with all the update of the content that I produce to conferences or blog posts on my GitHub profile page. So without any further ado, I think that we can start. First of all, let's have a look at the high level of the structure of the information architecture that we need to build upon data in order to make data actionable, drive insight, and produce value, tangible value for the business. Because data by itself have basically no value. Data gain value when it is put in use, when it is used, and when drive action that produce value for the business. So just to make an example, if now I say 11 is a number, and it's of course a data, but probably just by itself 11 have absolutely no meaning for you, and it's not usable in any meaningful way. In order to make data understandable and so make it possible to do some inference and start to have some kind of insight and drive some type of action, we need to put the data into a meaningful context. So we need to transform data in information, provide the context needed to understand the data itself. And to do that, we need to add to the data also metadata. Metadata provide the context and give the meaning at the data. So for example, 11 by itself have no meaning, but if I say that 11 is a temperature measured in Celsius degree, recorded this morning at 11 p.m. in Milan, these are all metadata associated to the number 11 that provide the context and make you understand what effectively the data means and make the data usable, transform the data and information that start to be usable. In fact, you can, for example, compare the temperature that I give to you in Milan this morning to the temperature in your city and find out if it's higher or lower, and maybe make some decision or further consideration. But that's not enough. When once we have put data into a context, adding the metadata, is also important to codify in some way, possible in a formal way that is machine readable, the knowledge that we have built upon this kind of information. Codify the knowledge means basically define what are the relevant concept, model this concept, so define for each concept the attributes that describe the concept and the relation between the concept, and also define the business rule that govern this relation or the evolution of this relation. So, for example, it's important to define in our example what is the concept of temperature, what is the concept of Celsius degree as a unit of measure of the temperature, what can be other type of measurement system for the temperature, what are the business rules that govern the transformation from one unit of measure to another unit of measure, or define a concept that can be correlated to the temperature, for example. The weather is a concept that is related to temperature. The outdoor activity that could be performed is another concept that can be correlated to the temperature. So, for example, if the temperature is around 11 Celsius degree, probably an activity, outdoor activity that is correlated, that can be performed, is go outside for a walk or for a run, but probably is not a good outdoor activity doing a bath in an open swimming pool because it is still too much cold to do this kind of activity. So knowledge defined in a formal way is a way to codify what we know about the information that we have collected, how it has been collected, and how it can be used to derive other information or to derive insight that can be used to then take some action. Last, the point of our pyramid is, of course, intelligence, because we want to leverage the knowledge on the information that we have collected, putting the data into the context by using metadata to derive insight. This insight can be derived by a human agent or by an artificial intelligence model, so through an algorithmic process that analyzes the knowledge, analyzes the information, and then the data, and produce automatically some insight that can be turned then into action. This is the high-level architecture, information architecture that we must to manage in order to make data actionable and extract the value from data, especially if you want to leverage all the potential that come from modern artificial intelligence technique, and in particular generative AI. So let's dig into each one of these layers one by one, starting from the foundation, that is the data layer. Sorry, before to dig into the each layer of the pyramid, it's very important to understand that in order to build all this architecture, we need to put in place and make work together different kind of stakeholder with different kind of knowledge. These must work as a team, as a cross-functional team together. So, for example, all the part of the information architecture related to the data, it's the area of expertise of the data engineer. But the data engineer must work together with the information architect that are more expert in how to structure all the metadata that is correlated and describe and put the data into the context. Moving one layer above, there are all the part related to the knowledge of the specific business of the concept that are important for the specific business, and the knowledge on how to translate this concept in a machine readable conceptual model that come from ontologists, for example. And at the top of the pyramid, there are machine learning engineers, data scientists that are able to translate the knowledge and use and leverage the knowledge to produce machine learning algorithms. All these personas must work together to create an architecture that is that have an holistic approach on the management of information, in which all the parts are correlated and work well together. So we have seen the architecture, and we have seen the different personas that work together to create this architecture. Now let's go inside each layer one by one, starting from the foundation that is the data layer. Historically, the data has been managed through data management solution that have a monolithic architecture. So basically are big box in which a central data team load all the data that come from operational sources and connect all this data in order to make it accessible and usable to implement the different use cases. Of course, this kind of monolithic architecture is very complex to be managed over time. The complexity of this architecture tend to become bigger and bigger as much data is imported and ingested within the platform. At some point, this platform became so much complex that are very difficult to be evolved, and the cost of maintenance skyrocket. So basically, this platform became a legacy, and a new platform is needed. And so basically, the new technology of the moment is taken, and a new platform, a new solution, a new data management solution is built from scratch, aside the old one that became a legacy platform. In a lot of organizations, this rip and replace approach to data management solution have brought the fact that the landscape is full of different ages of platforms. So we have the new platform that leave aside the previous generation, 2, 3, 4 previous generation of data platform, because every now and then there is the need to recreate the platforms from scratch, because the old one is became too much complex. But at the same time, it's not so easy to completely decommissioning the old one. So this approach is not anymore sustainable. For sure, it's not scalable and is not anymore sustainable. So all the modern approaches to data management push toward an architecture that is more modular, an architecture that is built as a composition of different modules, usually named data products, that allow to isolate the complexity in smaller parts. So I can change one part of the system without to be afraid to have a side effect on the other part of the system, or having to well understand how other part of the system work, because each modification can be made reasonable in an isolated way within the component I'm going to modify. What is exactly a data product? There are a lot of definition. This is the definition that I have defined in my book that will be published probably in September. Even this definition contains a lot of concepts. I do not want to unpack all of these concepts now, because it will take too long time, but just make a point. For me, a data product is any kind of software that in which the functionality are driven by the data. So the data is not just a byproduct to provide some functionality, to save the state of the object that are needed to provide some functionality, but is a software application that is based, that is driven by the data. And so the data is not just a byproduct, but it's the product itself, or is a core part of the product itself. Inside all the possible data product, there is a subclass that I call the pure data product. The pure data product are that data product, so software application that do not expose visualization or functionality driven by the data, but that expose the data itself. So expose a data asset in order to make it more relevant, accurate, usable, and reusable by composition over time to support multiple use cases. This is what I call a pure data product. So the main goal of a data product is to improve the potential value of a data asset, make it reusable, composable, accurate, and relevant over time. Okay, so we have defined the first level of our pyramid. So the data layer that is built as a composition of different data products. Now we can move up to the information layer. So as soon as we have our data product, an important problem that we have to face is how to make this data product interoperable. So the data acquire value not only when it is used, but also when it is combined. So it's very important to have the possibility to combine the data that come from different data products, join them, create a joint view to support a new kind of use cases. And when we need to cross-join the data exposed by two different data products or even more, it's very important that this can be made out of the box. So the data product should be implemented in order to make this interoperability as a feature provided to the consumer out of the box. There should not be the need to implement some new code, some integration project to join the data that come from two different products, but should be just a click operation, a very simple operation. So the data product must be interoperable at the technical level. In order to be interoperable, it's very important to have in place a governance, a central governance, a federated governance, a governance body that can define some standard specification protocols that should be implemented by the product development team in order to ensure the fact that different data product can interoperate smoothly. So basically, the federated governance team, define the rule of the game that each player, in this case the player are the data products team, must follow in order to ensure the interoperability. Another important part of this game is the self-service platform. The self-service platform basically has a goal of the fact to simplify and reduce the cost of development and maintenance of the data product. And for doing that, it focuses on all the standards defined by the governance team in order to make more easy for the data product team to implement and be compliant with the standard, and the others on the other side do the enforcing of the standard, so control if the data product effectively are compliant or not, and in the case are not, take some action to correct the behavior and the implementation of the data product that is not compliant. So in our data management solution, we have moved from a monolithic solution to a solution that is built as a composition of data product, and these data products are interoperable because on one side we have the governance that defines standard policy, all the rule of the game, and on the other part we have a self-service platform that help the data product team to implement and be compliant with these standards. This is what I have just said. So basically the concept here very, very important. One of the most important standard that is defined by the governance team is what is called the data contract. The data contract basically describe all the agreement that are defined between the data product owner, the data product itself, and its consumer. So contain all the metadata that describe the data exposed by the data product and the way in which this data is exposed to the potential consumer. To make it simple, it contains, for example, the schema of the data exposed, the constraint that can be applied to this data, and the API that can be used by the consumer to access this data and consume this data. So the federated governance team define the structure of the data contract, but do not compile the data contract for each product. The accountability, the responsibility to populate this data contract rely upon the data product team itself. So this is a way to push the management of metadata to the left, directly to the ones that have the accountability on data. These persons, this team, have also the accountability to produce the metadata related to the data that they are exposing to the rest of the organizational ecosystem. In this way, another important thing to underline is the fact that the life cycle of the data is perfectly aligned with the life cycle of the metadata, because it's not possible to publish in production a new data product without having also this data product paired with its data contract. So with all the metadata information that are relevant to describe the data product to the consumers, to the potential consumers. So the generation of the metadata is not something that is performed after the publication of the data product by a central team of data steward, but it's something that is performed while developing the data product, and the data product itself cannot be published or released in production if it is not accompanied by its data contract, and the data contract has been validated by the platform. So we have seen data managed as a different data product. So the data solution is composed in different modules that are data product. Each data product is paired with all the metadata that describe the data exposed by the data product to a data contract. Now we move at the knowledge level. So moving at the knowledge level, what is important to understand is the fact that till this moment, when we have talked about interoperability between data products, we have always referred one specific kind of interoperability, that is the technical interoperability, the syntactic interoperability. So made possible in an easy way without doing a new project, but in an easy way out of the box, connect the data that come from different data products. But there is another kind of interoperability, that is the semantic interoperability. Okay, I can join easily from a technical point of view the data of the customer that come from the marketing domain with the data of the customer that come from the sales domain. But in order to join and make usable this joined data, I need also to understand the meaning of the data that come from these two different domains. So the customer, what is represented as a customer in the marketing domain is exactly the same of what is represented as a customer in the sales domain or not. If the customer have a property that is the address for the marketing domain is the same thing for the address of the sales domain. So I have this sort of knowledge gap that create a problem in terms of interoperability at the semantic level. So the consumer, the potential consumer that needed to take data that come from data product that belong to different domain, have to do this semantic normalization, have to translate the way in which the data is modeled in the two different domains in a uniform way in order to make it usable and reachable and do all the stuff that is needed to support the specific use case that require this merge of data that come from different data products belonging to different domains. Of course, this problem is also present within the specific business domain, but is less significant because within a domain, the language used, the semantic used to model the data and the different data product exposed, it's very similar. There is not this big level of ambiguity, but when we move from one domain to another domain, different dialects are spoken. So maybe it's very easy that the same term, the term like customer, contract, mean different thing, maybe slightly different thing, or even absolutely big different thing in different domains. So this knowledge gap is bigger and require time to do the normalization in order to put together the data that come from the different domain and make it usable. Of course, push this work on the potential consumer is not scalable in the long term, and is also very error-prone mechanism because it requires a lot back and forward conversation with the different domain. The team that have to join the data need to understand the meaning that the data acquired have in the source domain and then do a translation. So there is a lot of possibility of misunderstanding in this back and forward process to map the meaning of different domain to a unified meaning. So it's very important to have a conceptual model, an enterprise conceptual model that create this unification of the meaning that the term can have in the different domains. But it's not implemented through a centralized operating model, so a central team that define the conceptual model and at the same time do all the stewardship activity to map all the data exposed by the different data product to this central conceptual model. No, it's not like that because also this operating model is not scalable in the long term, so it's more a federated approach. So yes, there is a central team that define the conceptual model, but then the link between the data exposed by the data product and the conceptual model is something that is shift left to the data product developer team. So it's a responsibility of the product owner and his team to expose the data in the format that it prefer, using the terminology it prefer, it's not a problem, but then define a link between the data exposed and the concepts that are present in the central conceptual model. So basically, this is performed weaving the data contract in the definition of the schema of the data. So the schema of the data is the physical representation of the data, how the data is exposed to the consumer. The semantic linking create link between the data exposed and the concept, or even the field weaving the data exposed, the data set exposed, and the property in the ontology, central ontology associated to a specific concept. So it's a distributed model of do modeling. On one side, we centralize the definition of the model. On the other side, we decentralize how the data is linked practically to this central model. On the bottom, the platform, of course, enforce the data contract at the syntactic level. So the structure of the contract, the fact that the contract have a schema and whatever, but do not enforce the linking with the conceptual model, just promote it. So just basically promote the fact that the product that define properly a semantic linking between the data exposed and the conceptual model are usually more simple to be discovered by the potential consumer, and so are more used, and if are more used, probably are able to catch more budget to be developed and extended in the future. Basically putting together a conceptual model that is an ontology basically with the data product, so creating this link between the data product and the conceptual model, and through the data product having the possibility even to access to the factual data. This structure is a knowledge graph. It's a knowledge graph built in a distributed way, and there is a type of knowledge graph that is usually named a virtual knowledge graph because the factual data is not instantiated within the central ontology, but the central ontology referentiate the data product, and then the factual data is accessed through the data product, but the data itself is not instantiated within the ontology, it remains on the data store of the source system. But anyway, this is exactly what the definition of the data is, basically exactly a knowledge graph. Arriving at the topmost level in our information architecture, we have the intelligence part. Of course, we have built this architecture, this information architecture with data product that allow the access to the data and create a bridge between the physical data and the ontology. We have created the ontology. The ontology, of course, contain all the business concept and the relation between business concept, but also contain all the technical concept, all the metadata represented through technical concepts that are linked to the data product. We want to make it easy to be assessed by external agent. That can be human or intelligent agent, like for example, large language model. So we need to have a platform. I like to call this self-service platform a data product catalog. You can call it data fabric, data mesh, self-service platform. It's basically the same things that we are talking about, but I prefer the term data product catalog because is not strongly linked to a specific approach to data management, but can be applied no matter what is your approach. The important thing is that you are building your solution as a composition of products. So central is the concept of product, but if you have a product in the data mesh or you are building product over a data fabric, is the same thing. So it's not so much opinionated to the specific approach, it's more general. But basically the idea of the data product catalog is to leverage the concept of data product in order to facilitate the definition, the construction, and the consumption of the information architecture built as a distributed and virtual knowledge graph. In particular, the consumption layer provides different services through which the external agent can assess the information architecture, can query the knowledge graph, and with the knowledge graph can move from business concept, technical concept, data product, and at the end arriving directly to the physical data. So for example, can be exposed an endpoint to query the conceptual model through Sparkle language, Cypher, whatever language you prefer to query the graph. There can be an endpoint to perform a search within a vector database that contains the graph embedding in order to locate the portion of the knowledge graph that is more relevant to the query or the problem that you are trying to solve. And of course can have different interfaces to move from the conceptual level to the physical level, to move from the concept to the actual data. Can be SQL, GraphQL, whatever is the preferred interface to assess the underlying storage system. Thanks to this data product catalog, it is possible to empower and fully leverage the potential of large language model to solve domain-specific problems. So basically, the user can chat with the large language model, but the large language model is able to interact with the data product catalog, performing smart search across the different endpoints that the data product catalog exposed to query the knowledge graph, and in this way can extract relevant information to answer to the specific question, information related to the domain. So in this way, the large language model is able to answer to questions that are domain specific, even if it has never been trained on that kind of knowledge. The possible outcome of this conversation with the chatbot, empowered by all the information that we have in our information architecture and exposed and made queryable through thanks to the data catalog product, are mainly of three kinds. The first is, of course, is obvious. We can have business insight. So we can ask a question about the business and query the ontology, the concept related to business, and then moving from this concept to the data, we can answer to this question, provide insight, and then drive action that help business to produce value, leverage large language model. But there are also two other types of possible outcome. One is what I call intelligent automation. So the conversation is not anymore between a business user and the large language model, but the conversation is between the platform services and the large language model. And basically what I'm querying is not the part of the ontology related to the business concept, but is the part of the ontology related to the technical concept. And the problem is not a business problem, but is an integration and automation problem in order to facilitate the automation and the management of the life cycle of the data product managed by the platform itself. So this can create an intelligent automation and intelligent integration automation, leveraging the capability of the large language model. Finally, the third possible outcome is the extension of our knowledge base. So the extension of the concept, both at the technical or at the business level, that are available in our information architecture, in the ontology of our information architecture, because the large language model can be also used to translate, for example, documents that describe a specific business process into new concept that can be added to the ontology, to new business concept that can be added to the ontology, or can be used to help in the curation of the metadata, so on the technical concepts that are present inside our ontology. So can be also used to model our information architecture and to extend our information architecture. So say this is my last slide, is the information architecture flywheel. This is very important for me because it's very important not to build this information architecture one layer at a time. So first the data, then all the metadata, then the knowledge graph, and only at the end the use cases. But it should be an incremental approach driven by the use cases. So first you select the use case that is relevant for the business, then you find out what are the data products that you have to implement, then you define all the metadata, all the data content that describe these data products, then you find out if your ontology should be extended with new concept in order to fit the new data product that you have developed, and lastly you leverage a large language model providing the context that you have created in your information architecture to extract insight. Last thing, this last row, this is the very last thing, of course, as I said, you do not only leverage large language model to produce insight, giving the context that provide for your information architecture, but you can use large language model also to extend and curate your information architecture. So you have a positive feedback loop that, in my opinion, is good if you start to put in place as soon as possible, because this creates value in a cycle. So every iteration, you have more value, you have a better and more strong and solid and complete information architecture that generate better results from the large language model and allow you to create more data, more information, and a better information architecture. So it's a virtuous cycle, it's a flywheel that I suggest you to put in place as soon as possible. Thank you.
Thank you, Andrea. Questions. Yeah, follow Andrea on LinkedIn. He's regularly putting out very useful imagery. I don't know if you draw it by hand or if you have a particular
No,
tool.
I use Draw.io, but I like to use the modality sketch. So it seemed that I have drawn by hand, but I'm not able to draw by hand so well. So it's just...
I was going to say it's too consistent. I suspect that there's some tooling used. There's some people that are asking if we're going to share the presentation slides. I leave that up to you, but
Of course, yes. I think that Joaquin, you are taking care of the recording. Will be soon on YouTube. About the presentation, I will create a PDF version, and if you go on my GitHub profile, there is all the content that I publish, and so in the next day there will be available also this presentation in PDF.
Perfect. If you have any questions, comments, concerns, or anything else, you could put that in the comments below. And as we get through the week, Andrea will be able to go in and respond either individually or privately. So feel free to write to us. I do want to say, just from my own perspective, if I can encapsulate this, we want to create value from data, right? We need a holistic approach to tackle that. Right now, it's a fragmented approach that is centered around the usage of applications to solve individual use cases. That's a problem because data is knowledge is reusable, And we really created these data machines to act as intermediaries between people. But what's happening now is that they're only fragmenting our understanding and our ability to communicate with each other further. Um, so the only way we can create a unified and a competitive advantage with data, information, knowledge is by creating this shared understanding of reality. And that is achieved through semantics, integration of metadata, data infrastructure, and everything else you covered in this presentation.
Exactly, exactly. If we do not have a shared model within a company, even a simple one, we cannot pretend that the large language model is able to infer it from us directly from data. Of course, it can try, because you can pass just the physical metadata, so the schema of the data, and it can try to infer your semantic model, but it incurs in a lot of hallucination. So the performance is not so good. Instead, if you create the model, a good model that is shared among all the stakeholders, then you can pass this as a context for the large language model, and the performance in the question answering is much, much better.
And I think you also painted a very clear picture that this is not a one-time exercise. This is an ongoing exercise. I mean, we wake up, we live our world, we experience new things throughout the day, and we learn. An organization is a composition of people. There's a decentralized group of people that are learning every day in different environments, in the front line, in administration, at a high strategy level. And we need a way to share that conceptual view. And we need to have a means of contributing to that view. Otherwise, we're living in the age of the dinosaur, where we have tribal knowledge and we have to draw pictures of caves and grunt at each other that the buffalo are running that way. You know?
Exactly, exactly. For this is very important to proceed in an incremental way, not in a waterfall way. So start from the use cases, but then create component at the level of the information architecture that support a specific use case, but that are designed to be reusable even for the next use cases, no? In order to be more fast at every iteration, because you have more building block that you can compose to satisfy new use cases without rewriting them from scratch. So the idea is be driven by use cases, but have engineering to order approach. So building something that is usable only for that use case. Build component that support that specific use case, but then can be reused or recombined to support also other use cases.
I think a very and I'm going to be very sensitive to time because you do have to drop in the next few minutes. Uh, One common theme that I've heard from the perspective of knowledge and acquisition of knowledge and human to machine engagement is queries. I mean, we're not going in databases because we love schemas, because we love to write queries. We're going there to gather data or information that allows us to take a decision. So what I've heard and what I've understood and what I acknowledge to make sense logically is that one of the simplest use cases is answering one or a few questions. And as you continue to develop this use case, you can expand the kind of questions and the complexity of answers that you can get from that kind of system.
Absolutely. I think that nowadays the most popular analytic system in the world is probably is Excel. Okay, but I think that no one really loves Excel because we are human. We prefer to have a conversation. So we use Excel because it's simple from a business point of view to put some data, do some wrangling, and having some answer. No, it's the real self. It's the realization of the ideal of self-service BI. No, because you can put the data. It's very simple. The business can use it, but everybody prefer to have a conversation, make some question, have an answer, then do another question, ask for a clarification, and the large language model are quite good to generate SQL query. So if you put the right context in terms of the conceptual model, the concept, it can resonate on the concept and then move on the SQL query. It's very simple to extract the data. But to reduce the hallucination, you have to understand what you are talking about. And so providing the context in terms of portion of the ontology is very important.
We have a few questions, but again, as we stated,
I have 3 more minutes, so if you want to take one and then for the other, no problem. You can contact me directly on LinkedIn, and I will be more than happy to answer.
Tom the Wolf, he's the first one, so he gets a preference.
First in, first out.
Do the domains have the autonomy to define their own ontology for their domain? And are these domain ontologies then connected through a higher level ontology?
Yes, sure. I return to this slide. So it's the ontology can be divided in 3 layers. So you can have an upper ontology that define very generic concept. What is a person? What is a relation? What is a location? What is so very high level concept. Then you can have your domain ontology that is defined centrally. So for example, you can define what is an order, what is a product, what is a customer, okay? Then a complex subdomain, so the marketing, the sales, can extend the domain ontology, specifying, adding some more information. So, okay, for all our company, this is a product, and this stays in the domain ontology, or this is a customer. But in the sales domain, a customer, there is a subclass of the customer as defined in the domain ontology that is specific for the sales domain. And this is the good thing of the ontology. They are graphs. So there is a plasticity. You can extend the different concepts in a very easy way. So are not separated ontology, but are part of the same ontology because everything is correlated with everything. So we have small number of concepts in the upper ontology. We have a more number of concepts in the domain ontology, but usually are quite general. And then you can have specialization at the level of each subdomain. And you can move in this graph to understand what we are talking about. We are talking about a general customer, or we are talking about the customer as defined by the sales domain.
Thank you, Andrea, for your wonderful presentation. And yeah, have a good rest of your evening. Thank you, everybody, for joining.
Thank you.
Feel free to contact Andrea directly or add comments below.
Thank you. Have a nice day. Bye-bye.